Good evening, or should I say good evening? I always wanted to say that. I'm just excited about tonight's guest. Welcome to the show. I'm Martin Willis, your host. And like I said, I'm super excited about our guest tonight, Professor Kevin Knuth. And you know, when people in the UFO community say, why aren't scientists taking the UFO subject seriously and looking into it? Well, there you go. He's well respected as an associate professor in the Department of Physics at the University of Albany. And he is the editor-in-chief of the Journal of Entropy. He's a former NASA research scientist, having worked 4 years at NASA Ames Research Center in Intelligent Systems Division, designing artificial intelligence algorithms for astrophysical data analysis. Is that sciencey enough for you all out there in the UFO community? I think it is. Before we get started, I do want to thank everyone who supports the show. I really do appreciate it a lot, and without your help, I could not go on, so I really appreciate that, and I appreciate every single listener. And if you're on the edge for supporting the show, you can do that for less than a cup of coffee, only $2 a month over at Patreon, and the links to that are on our website, Podcast UFO. While you're there, check out this week's great blog by our blogger. He's done a great job for quite a while now, Charles Lear. And the title of that one is called UFOs and Humanoids in 1973. There was some strange cases that year, including the Pascagoula case. So do go and check that out. Next week, I do want to say, it is all about you, the listener. It's a call-in show. We're making an experiment. We're going to try that out. And I know I can't talk for 2 hours. We are going to have Race over here at KGRA doing the call screening. Thank you, Race. And we hope to hear from, if you listen to the show in other ways, over at the Dark Matter Digital Network or on YouTube, or you are a listener to the podcast and, of course, are on YouTube all the time. We'd love to hear from you, and that is next week starting at 6 to 8 p.m. Eastern Standard Time. And now that is -4 GMT instead of -5, because we had a time change last Sunday. And without further ado, I'm going to welcome our guest. Welcome to the show, Kevin.
Thank you very much for having me.
And you remembered to unmute your mic. That's great. Thank you. That's about a 50-50 on this show. So I'm really glad to have you on, Kevin, for so many reasons. I know that Alejandro interviewed you. I just found that out a day or two ago.
Yes.
He was at that conference where you did your talk there. Was that about a year ago or something like that?
Yeah, about last year this time, yes.
And if you could tell the listening audience, what made you decide to tackle this interesting topic? I think it's interesting.
Oh, that's a good question. What made me decide to tackle it? A moment of insanity, perhaps. No, but seriously, I think I found the revelations of the ATIP program quite compelling and quite interesting, and I have long felt that scientists ought to study these things rather than just joke about them, and so especially when I heard about the conference that the Scientific Coalition for UAP Studies was holding, I thought, well, I would really like to go to this and find out more, and so that's pretty much what got me interested in this.
And had you yourself ever had any type of sighting or anything?
That's hard to answer because I had seen something unusual that I really just thought was a weather balloon at one point. It was while I was in college working on my bachelor's degree, and I was working as a computer scientist at Mercury Marine in Wisconsin, and I was coming out of work. It was afternoon, probably around 3 or 4 in the afternoon, and I saw an F-16 flying, and got very excited about that, and that was not horribly unusual because I grew up just south of Oshkosh, Wisconsin, where they have the Experimental Aircraft Association fly-in. So the EAA fly-in is there. And very often we'd see warbirds flying. But that really wasn't until near the end of July. So this is probably early June, and I saw an F-16, and I thought, wow, an F-16. I thought, what is it? What is an F-16 doing here? So I ran to my car and got my binoculars. I'm a bird watcher, so I keep binoculars in my car, and grabbed the binoculars, and I looked and realized there were two F-16s, and they kind of split up and came back around. And as I watched, I realized that they were basically flying around a metallic sphere that was just hovering there in the air. And the sphere was about a third of the length of an F-16. They were right next to each other for direct comparison, and I assumed that I was watching some kind of exercise, and I just imagined it was a weather balloon, and they were practicing taking out weather balloons or something. I don't know. And so I watched through binoculars. I had a very clear view. It was a clear sky, on a bright summer day, and I watched for about 3 minutes, and this is where I made my mistake. I thought, oh, my brother has to see this. So this was before we had cell phones. This would have been back around 1987. And so I thought, my brother has to see this. So I hopped in the car and raced home to get my younger brother. And by the time I got home, which was about 10 minutes later, I grabbed him and went outside, and everything was gone. The smoke trails were gone, and so on. Oh, I forgot to add that while I was watching, during those 3 minutes, two more F-16s came in from the west, from another Air Force base, and all four of them were buzzing around this thing like bees.
Wow.
And it was very cool to watch, but I really imagined that I was watching an exercise. And so, but I don't know what happened to the sphere. The sphere was gone and the F-16s were gone. So by the time I'd gotten to my house, so I don't know how the thing concluded. And for years, I just imagined that it was an exercise with weather balloons. And at one point, I was talking to a friend in the Air Force, and I mentioned this story, and they looked at me quite surprised, and they said, "Well, first, they wouldn't have been conducting exercises over a city." And they also said, and also you don't fly an F-16 or a jet aircraft like that anywhere near a weather balloon because you're going to suck it into the air intake and bring the plane down. And they noted that the fact that there were two F-16s from one direction and two from another sounds like a response to an urgent threat. So their assessment was that they were actually responding to a threat, what they determined to be a threat, and were actually engaging something. So looking back, I wish I would have known that, because I would have watched for longer with more enthusiasm. But yeah, it was quite exciting.
That's a great story, and there is so many similar stories of fighter pilots and the afterburners taking off after these things, chasing. A guy I'm in the antiques world, and an antique dealer, a friend of mine in Canada, was talking about being at a party. I think it's a great story. When he found out that I did a show on UFOs, they had a party at his house, and they were all outside during the summer on his deck. And someone, said, "What is that?" And they heard this noise, and they saw this perfectly shaped disc going really fast, and two fighter jets with their afterburners on chasing after it. And then they saw it zig back, and it was still being followed, but the thing had got some space in between them. So he
wow, that sounds really exciting. For me, the sphere was just sitting there motionless, so it wasn't as exciting.
That's still really interesting. But anyway, the thing that he impressed him the most was, first of all, no one at the party wanted to talk about it. That was the first thing. And the second thing is, he scoured the newspapers and everything. He said he just couldn't believe it. There was no reports anywhere about it because it was so fantastic. So,
wow.
Yeah, but
yeah. Well, I mean, that being said, I never reported my encounter to anybody, and like I said, for a long time, I really just thought it was an exercise with the weather balloon. So there was no real compulsion to report it.
Right. And in 1987, well, where would you report something like that? I mean, you wouldn't
Yeah, I don't know who I'd
source
call.
online you wouldn't think of, and I would have had no idea. I mean, the only time I saw something, I called the Air Force Base nearby. I didn't know what else to do. Yeah.
Right.
But
I could see that.
right. And so, what has the road been like for you through NASA and all the other things that you've done to where you are today, and what made you actually write the paper you recently did?
Let's see. I think that trying to think of what the most important events were. I've always found the topic interesting since I was a kid, and of course your imagination runs wild. What if, which is great fun. As a scientist, that's tempered by your knowledge of how things, of how we understand things to be in the universe and how to understand physics and engineering. The ability to travel between the stars, it's clearly is very, very hard for us to imagine how to do this. And so that tempers your enthusiasm a little bit. But but I always appreciated the fact that science studies things that are controllable and reproducible, and that's really where the power of science comes in. And when you are studying something that's not reproducible or you don't have any control over, it's extremely hard to do. And I think back to a time when I was at NASA Ames and I was doing research on studying planetary nebula, which are clouds of gas surrounding dying stars. We had a local poster session of just presenting our research that was funded by the center. And my poster was next to a poster from a gentleman named Friedman Freund. And his poster was on earthquake lights, which I at that point had never heard of. And so I we're standing around talking to people about our research, but when your poster isn't busy, you wander around and look at other people's. So I remember I was looking at Friedman Freund's poster and started asking him some questions and asking about earthquake lights. And he said, well, when there's earthquakes, people see these orbs of light appear, and or you can see jets coming out of the ground of light, and these things aren't studied. In fact, most people don't believe that they're real. At the time, the general belief was that people in earthquakes were panicking and hallucinating. And I thought that was kind of amusing. I thought, well, you can't have everybody hallucinating. It's kind of silly.
Exactly.
And his whole take on this, his research was trying to understand where these lights could come from. And he was proposing that stress in the Earth's crust would put huge pressures on quartz crystals that would then act as piezoelectric crystals, giving you large electric fields, which could ionize the air and create these lights. And I thought it very reasonable explanation. It hinges on the question as to whether rock can effectively conduct current at those potentials, and that I just didn't know, and that's what he was actually researching. So I thought it was pretty interesting, and so I asked around some of the other scientists, and I said, "Yeah, did you see the poster next to mine? Is kind of interesting. What do you make of that?" And everybody really poo-pooed it. They were all, "Oh yeah, that's Friedman Freund." He was I think maybe in his 60s or 70s at the time, and everybody pretty much said, "Yeah, he's been going on and on about earthquake lights for years, and he believes that they're, created from stress in the Earth's crust, and it's really all just nonsense." And that was pretty much everybody's take. And I was kind of disturbed by this. I thought, but he could be right. It's a plausible explanation. We just don't know much about conductivity of the Earth's crust and these sorts of things. And then I pointed out, if it's true, then what that means is you could probably detect earthquakes before they happen by measuring electric fields. And everybody goes, "Yeah, I suppose, but we all know that earthquakes aren't predictable anyway," and blah, blah, blah. And I said, well, we've been told that because nobody figured out how to predict them, but he might figure it out. That's interesting. So I always remembered that, and I was always kind of disturbed by people's reactions to his work. And it wasn't until, maybe, what was it, 2015, just a couple years ago now. I think was an earthquake in Chile and Japan where they captured earthquake lights on security cameras. And so now, actually, if you Google earthquake lights, you'll see articles about earthquake lights. And who are they interviewing? Well, they're interviewing the only expert in the world on earthquake lights, who's Friedman Freund, this one guy who had the guts to study it, which I was really impressed by. I thought that's really interesting. So when I did encounter the possibility of studying UFOs, I thought, well, this is going to be risky, and people are going to have mixed opinions. Scientists especially are going to have varying opinions on this, not all positive. But as long as I research this carefully, like I would any other scientific topic, and then I don't see what I'm doing wrong. I'm not doing anything wrong. It's hard for anybody to really criticize me. I mean, they may try and they may succeed to some degree, socially, but I think this is a good path, and somebody has to study these things. And right now, from a career perspective, it's potentially damaging, if I go on and start spouting off things that I don't really have data for, which I'm very careful not to do. But in the event that I do collect data, or we start to understand what these things are, I'll be one of the only experts in the world who really understand these things scientifically, and that's a good position to be in. So yes. I don't see any reason not to study them. In fact, this is precisely the topic that if I walked away from it, I can see myself kicking myself in the future, thinking, what were you doing walking away from this? Who would walk away from it? It is potentially one of the biggest discoveries in human history. I can't say what these things are. They appear to be structured craft. Are they extraterrestrial or not? We don't know for sure. And if they are, it's a huge discovery, and if they aren't, it's still a huge discovery. So I don't see any way to lose here.
Right, and I would argue that it would be the biggest discovery, ever made by mankind.
I would think so too. Yeah.
And and thank you for doing this, actually taking the risk, because like I mentioned in the intro, a lot of people would not ever look into this or think it's a silly topic, just like the earthquake lights. And it seems to be going in the direction where more people are taking this a little bit more seriously. I had the sighting I had, I couldn't explain what it was, and that's what made me curious, and that's what makes me have the show today. And and I'm not saying I know anything closer to what they actually are than I did when I started, but it's still a fascinating topic, and one with so many possibilities. And anyway, I'm really glad that you're taking this seriously. And one of the arguments that I've heard people talk about when it comes to science and taking this seriously is the fund money. Like, if you can't resolve something within a certain period of time, then there's no such thing as funding for it. And I do understand that, and it's not something that can be replicated easily. It just either happens or it doesn't happen. It's fleeting. So what are your thoughts on all that?
My thoughts are we are trying to get funding from private sources. I've done a lot of research without funding. You kind of do it on the side in your spare time and do the best you can. It means that you can't buy equipment usually. You can't travel places to meet with other people who are studying it. You have to pay for those things out of pocket, which I've done before, and I'm doing that again now. So I think it's important to study this. We've known about these objects for, since the 1940s, but the sightings go back much further than that. And clearly this is important, and it's unfortunate that the attitude of the scientific community is that the study of these objects is unscientific. And it's ironic that that attitude inhibits scientific study. So just declaring something unscientific means that you don't study it, which makes it stay unscientific. But what that also does is it perpetuates a state of ignorance. And at this point, now we have enough evidence from the U.S. Navy where these things are interfering with military aircraft during military operations. That's a serious issue. And so now, what do? We've perpetuated the state of ignorance for 70 years, and that's incredibly detrimental. And we don't know what the situation is. I don't believe that these things are hostile, whatever they are. There doesn't appear to be much evidence that they're hostile, but if they wanted to be hostile, we would be in big trouble.
Absolutely.
And so this is potentially one of the biggest safety or security issues we've ever come across. And again, people aren't paying attention. And I know people in the military are surprised that the Navy and the other military branches aren't that interested. I mean, this is something that we should all, if they had a sickle and a hammer painted on the side of one of these craft, we'd all be up in arms. Literally, I mean, we would be at war at this point. But that's not the case, and so people aren't worried. But that's really pretty ridiculous. And so I think it's this, it's the belief that this can't be possible, which is, stopping us from understanding what the situation really is. And I think that's a pretty silly response on our part.
Have you heard of Stanton Friedman?
Oh yeah, yes.
Well,
I never had the pleasure to meet him, but I've watched several of his talks on YouTube.
Yeah, he was a real gentleman. One of his things that he liked to say is about the skeptics out there. Well, if this was happening, I would know about it. That's kind of the ego-driven look at it. Unfortunately, that you do hear, not exactly in those words, but that kind of sums it up. And it's kind of surprising that SETI does not even want to admit that there's a possibility that we're being visited.
Well, I think they, like many areas in science, are worried about funding.
Exactly.
And for them, they've been on the fringe since their inception, and they try to mitigate the degree to which they're on the fringe, and I think that's why they stay away from it. And now at this point, it's just cultural.
Yes.
But it's for me, it's surprising because I know of serious scientific efforts in SETI to look for extraterrestrial artifacts in the solar system, on the moon, on Mars, on asteroids, and at the Earth associated with the Lagrange points. So there are active searches for artifacts in the solar system, but are they in our atmosphere? No, not possible. Yeah. That's kind of ridiculous. If somebody is seeing something unusual, you're going to want to check it out.
Yeah.
On one hand, it's unfortunate, but on the other hand, I see it as this is an opportunity for me and the other scientists now who are getting into this, because there are others, and this leaves the field wide open for us to make the discovery. So now it's fine. Right now it's fine with me. They can keep listening to listening for radio stations, and I'm gonna track down some of these craft. That's all there is to it.
Excellent. Okay, well, we are going into break, so hang in, everyone there. We'll be right back right after these messages. Welcome back. This is Martin Willis, and my guest this evening is Kevin Knuth. And we were talking about SETI when we went into the break. And I had Seth Shostak on this show a few times. And we always get into the debate of UFOs, and oh boy, some listeners get really angry about because he's very good. He's very bright. He's funny. He's a nice guy. But basically, his argument is that he needs physical evidence, lots and lots of physical evidence, enough to fill. At one time, he told me he needed to fill a wing. We needed to fill a wing in the Smithsonian before he would take this seriously. And I said, well, what about dark matter? How much evidence do you have of that? And he said, well, he had all kinds of evidence of that. And but anyway, it's useless to argue with someone that already has their mind made up, you know.
Yeah, and I think the other problem that you run into is that astronomers especially are have a we each have a personal history where we've had to argue against pseudoscience like astrology.
Oh yes.
And I think as educators we're trained to not not be tolerant of that kind of ignorance and to try to set people straight. And so I think that a lot of times when you see especially some of these prominent popular scientists speaking about UFOs, they have in their minds that this is a pseudoscience, and so they really feel that it's their duty to set people straight. Um, Unfortunately, this hasn't been, unlike astrology, which had been looked at for a long time and morphed into astronomy. This hasn't been studied well, and that's really the big difference. And I think it's important for them to keep that in mind. Now, there is some evidence, and I think there's enough evidence for us to look at it more closely. There's not enough evidence for us to say, yes, they are definitely extraterrestrial. Yes, they're definitely aliens. But there is some evidence that these things do appear to be structured craft.
Hmm.
And that's concerning.
And what about, there are claims, I don't know what I think about the claims, but there are many claims going all the way back to Roswell that there's been crashed vehicles. And, the argument often you hear about that is how could they travel, light years away or whatever it is to get here and then crash here? It's ridiculous, that type of thing. There's, and I don't really know if that's so, if, someone like Bob Lazar actually did see, a craft, if, that the government has tucked away. I don't. I've said many times in the show that I don't really buy that, and a lot of people really stand behind Bob Lazar. So I'm expecting hate mail already for saying that. But anyway, what are your thoughts? And I do believe that TTSA is saying that they have some crashed saucer or crashed UFO material that's going to be exposed soon, and also in the movie Phenomenon, the Phenomenon that is, supposedly there's going to be something revealed in that as well. What's your thoughts on that whole topic?
So I've had to kind of adopt this degree of belief where I kind of rank what I hear from people, because I'm now in communication with people who are, formerly with the Pentagon, or former Navy people and other scientists. And if I hear something from one person or maybe two people, then I consider it to be a rumor. If I hear it from many people, supported from many different angles with different pieces of evidence, then I take it a little more strongly. So at this point, I guess I've heard rumors from various people that we have crashed craft in our possession, and so I suspect that it's possible that we do. I don't know any of the details. I've heard some details, but I don't know how true they are. And so I kind of take that with a grain of salt, but I basically tuck this away as this might be true. And that's I think the best I can do in this kind of situation, where you're hearing anecdotal evidence from various people who do have access to these sorts of things. And it's a difficult, so this is a difficult subject to tread.
Mm-hmm.
Is it possible that craft could have come here? I think it's possible. And, is it possible that you've had craft here and have crashed? I think that's possible too. Earth is going to be a relatively hostile place. And so,
Mm-hmm.
It's not like flying around Mars. And so, and flying around Mars isn't that easy either. We've had crash craft on Mars. So I don't, I expect that, somebody who's mastered interstellar travel to some degree is going to be, better at this and probably have fewer crashes. But the other fact that we don't know is we don't, if these things are structured craft from somewhere else, we don't know how many structured craft are present on Earth at any time. I actually I was at the SCU meeting in Huntsville last year, during Lou Elizondo's talk, I had the chance to ask him that question. I asked if they had any estimates as to how many craft were present on Earth at any time, and he didn't have an answer for me. And in fact, he wanted to ask that question himself. And so we don't know. Are there 10 of these things on Earth, present on Earth at any time? Are there 100 of them, or 1,000 of them, 10,000? We don't know. But if you have a large number of them, 1,000 of these things on Earth at any time, then the probabilities for a crash go up. So the probability of having a crash is going to be proportional to the number of objects flying around, right? And especially in New Mexico, at the time in New Mexico, that's, this is the 1940s, and so we were developing nuclear weapons at the time. We were doing missile tests. We were testing a lot of things, and from some of the government documents that I've seen, we knew that there were these unidentified objects present, and they had actually contracted people to look for them. And so, but we don't know, it's possible they were actively trying to shoot them down, and or take them down in some way. And if that's the situation, then they might not have just crashed. We might have actually brought some of these things down. So there's a lot of questions here, but they really depend on what we actually know about whether these things are really craft, how many are present on Earth at any time, what these craft are up to. They're often seen in sensitive areas. We know about incursions on nuclear weapon sites are quite prevalent, and so if these things are coming to Earth and hanging out in sensitive military areas, well, you might expect some of them to crash. That's going to happen.
I know there was speculation early on that, perhaps radar somehow affected them. Of course, this is all speculation, of course.
Yeah, it's all speculation. It's not clear what the situation. It's not clear what the situation is, and it's not clear how many crashes there actually have been either, if any. So this is all very problematic because we don't have a lot of evidence. We have a lot of anecdotal evidence, and you've got what I call a low signal to noise ratio, where you've got a lot of noise that's coming from misinformation, disinformation, mistakes, people, promoting fraud and making up stories and all sorts of things. So it's a horrible mess that you really can't begin to resolve by, looking at past cases. The only way to really get anywhere is to go out and try to collect data on these things ourselves. Right. Currently. I think that's the only way to proceed at this point. If you try to go chase past cases and interview witnesses and that, yeah, it's fun and interesting, but scientifically it's not going to get you anywhere.
Scientifically, yeah, the magic word. And, I never thought of the numbers game when you're talking how many are here. So now I'm going to ask you a question I've asked a number of people on this show, especially with your background. There are people that have speculated that, or the science has speculated that there could be, possibly millions of planets out there in just this, maybe even billions, with intelligent life in just this galaxy. And why would they be coming here? That's the question I have. What makes us so special if we're just part of a chain of, say, up to, millions of planets that have intelligent life, perhaps beyond ours?
Why not come here? How much money do we spend studying things on Earth?
Exactly.
A lot. All of our scientific research happens on Earth, and we still are finding things to look at. I don't see any problem with coming with Earth. Earth is fascinating. Earth is interesting, and it's interesting to us who live here. Somebody who doesn't live here is going to find it equally and more fascinating than that. Where we've been fascinated with Mars. We spent billions of dollars trying to get to Mars, and why Mars? From photos from the surface, it doesn't look that interesting, but we're still fascinated by it. I think that if we found life on another planet in another nearby solar system, we'd be working like crazy to get there, and we'd be collecting all the data we could from that place. And if we found life on 10 different solar systems nearby, we'd be trying to collect data on all 10 of them. I think that it's really naive to assume that Earth is uninteresting. I remember there was Stanton Friedman had complained about, I think one physicist had talked about a UFO sighting where somebody saw beings walking around in a meadow, investigating, doing something in a meadow. And the scientist said, "Why would you come all this way to poke around in a meadow?" And I thought, where else are you going to poke around? What an interesting place that would be if you were from another world. I could spend hours in an alien meadow if you put me there. So I don't know why people's brains kind of go out the window when they encounter this problem. Earth is interesting, and it's going to be more interesting for somebody who isn't from here. I don't see a problem with that.
Okay, that's really a good point. I appreciate that. I would think that possibly where they're from could be equally interesting as well, possibly. And
Yeah.
what do we? I forget how many millions of species we have on Earth, but there's a lot. There's a lot going on, and
it's certainly Earth is very diverse, which is interesting. Now, if there is life on Mars, which we haven't resolved that issue yet, it's very probably microbial,
mm-hmm.
and the diversity there isn't as great as it is on Earth. We know that much. So even though life may exist all over the universe, and maybe intelligent life all over, we don't know how diverse many of the other planets are. We still wouldn't know how unique Earth is, until we have some idea of what life is like elsewhere and what various things can happen. It could turn out that Earth is still a very unique place. We run between this bipolar way of looking at us and looking at humanity and looking at Earth. On one hand, we're the center of the universe, and then we realize, oh, we're not, and we kind of flip over to how we're probably not interesting at all, and the next minute we're the center of the universe again. And I think it's such a binary way of looking at things, and it isn't binary. These places are all interesting.
Speaking of binary, since you have your background, most solar systems aren't they? And how would you think that would affect a life evolving differently?
Oh, that's a good question. We don't. This is really an exciting era in human discovery, because we are, especially as an astronomer and an astrophysicist, I really feel that we are for the first time really beginning to get an understanding of what the universe is actually like. And with the exploration of the solar system really happened during my lifetime. I was born in May of 1965, and the first Mariner flyby of Mars happened in July 15th of 1965, I believe. And then it was literally 15 years later, to the day, that we had New Horizons fly past Pluto. So the last 50 years we've explored our solar system. That's phenomenal, and it's been a great pleasure and privilege to be alive during that time and watch it happen. But now we're starting to find out about planets around other stars and what are other star systems like, and we're starting to be able to look at spectra from these planets and identify chemical constituents, and we might be able to identify an oxygen atmosphere at some point and say that world's probably alive like Earth, and it's very exciting. And I think that it's important to realize that we really don't know anything yet. We don't really have any, we have some ideas of what it's like out there, but those ideas are really very naive, and I think that's important to keep in mind.
Exactly. And do you think the James Webb telescope is going to be able to have us discover more ways to look for life out there?
Yeah, certainly it will. And each of these telescopes going up and new missions that are currently on the drawing board are going to be very, very interesting and very exciting. We're going to there's a lot to learn, and we're going to learn a lot. It's going to be very, very thrilling ride.
I was thrilled to actually get to see that being worked on with men in white suits and um, protective gear working on that at Goddard. I think it was 4 years ago now. When I
Yeah,
went,
that's about. I was at Goddard about 4 years ago too, and I got to see it as well. It was really exciting. It
it
was
really
exciting to
is.
see this
Yeah.
thing and thinking, "Wow, that thing's going to be in space, and I'm going to be analyzing data from it in no time." That's
Yeah.
really great.
Yeah. That is amazing. And actually, I was down there visiting Ray Stanford, who listens to the show a lot, and his wife was working over at Goddard, and I was surprised that a couple of people there actually are interested in the UFO topic and talk about it openly. What was it like when you were at NASA? Did that subject ever come up?
No, it didn't come up, and the few times I tried to bring it up, it was really pretty much shot down as being ridiculous, and
Oh,
I always felt kind of some bad about that. I had hoped that people would be more open to that possibility and interested, but it didn't appear to be the case. Um, yeah, I've read about Ray Stanford, and I would really like to meet him. He sounds like a very interesting person, and I also have a past history of liking paleontology too, so that
oh,
he's even doubly more exciting.
that is. I hope he's listening tonight and he calls in. I'll give him a nudge when we get to our second break. Um,
Oh, I'd love to be in contact with him. That would be great,
I
great
can
fun.
definitely arrange that. I'm sure he'd love to be in contact with you as well. I know his
Right.
discoveries of those the footprints. I think there was unknown species he discovered, and just amazing. And actually, right near the grounds of Goddard, which is really
Yeah, that's
ironic, isn't
that's
it?
that's so remarkable. And what really amazes me about that is that the rocks in that area were not thought to be able to have fossils. And it really just shows how, we can fall into these traps of thinking that we know the situation scientifically where we really don't. If you don't look into these things, if you don't study something, you aren't going to make the discovery. And you know, and he and he stumbled on some of these footprints and had the visual acuity to recognize that, wait a minute, that's a footprint. and and wasn't concerned about the type of rocks and whether that was thought to be possible or not. And that allowed him to make the breakthrough, which is really fantastic. But I think it's a good lesson that we have to keep learning. It's very easy to assume that we know everything already, and the fact is we don't.
We've always thought that as a species, haven't we?
Yeah, we're very egotistical. We're very egotistical this way.
Yeah, like we are the center of the universe, and the sun goes around us, and it just keeps going on and on and on, and
That's right.
just to think, and only I don't know, it was just over 100 years ago, we didn't know there was such a thing as other galaxies, which is
That's right. Yeah, exactly. Yeah.
really amazing.
Where
Um,
dark matter and dark energy are now on the forefront of discovery. And the dark matter looks like it comprises about 70% of the universe. And what that means is that we are ignorant as to what 70% of the universe is even made of, which is mind-boggling. So it's very humbling.
do you think, not to take too much of a jag from the topic that we're talking about, but do
Yeah.
you think there are possibilities that perhaps we don't know? Ray Stanford just wrote he is listening.
Wonderful. Hello.
So, so hopefully he'll be one of the callers when we take calls coming up. Um, do you think that there is a possibility that we don't know something about gravity or something else that makes us think that there is dark matter and dark energy out there? I mean, do you think it could be a flaw in the way we're looking at things, or do you think it's actually has to be something?
I think the situation's very delicate because we have a great deal of evidence that there's something amiss with gravity. and that at the moment it appears that the explanation that there's other mass out there that we don't know anything about, invisible mass that we don't know anything about, appears to be the most plausible explanation. Where I would urge caution is the fact that we have several different pieces of evidence. One is the bullet cluster and the behavior of the visible matter there, and you have other situations as well. We have made the assumption that those are all representative of the same phenomenon, and it's possible that they're not all the same phenomenon. We could be wrong on many points. There could be a kind of matter out there that we don't know anything about, dark matter. It could be that we are also wrong about gravity, and it's not a binary situation. And I think that that's something to keep in mind when you go forward in these directions.
Most people that have your background are pretty solid on the Big Bang Theory, and I would guess that you probably are too?
Yeah, I am pretty much, yeah.
Mm-hmm. And there really can't be, as far as we can figure out, there can't be any other answer for how things begin. But it's still, if you really dissect that, it's how can something start from basically nothing type of thing. It's a bizarre situation.
At that level, it's a bizarre theory. Even as a theorist looking at this, it's bizarre that you could have this whole universe come out of a quantum fluctuation. I guess I would worry that any other quantum fluctuation happening could create another universe at any time. What that might do to this one or not. You worry about these things, and because it is bizarre, the facts that there's a lot of evidence that gives you faith in that theory, though, and that's the fact that the galaxies the universe is expanding. Mm-hmm. You run it backwards and it will contract, right? So it came from something that was much more compact. That's clear. You can calculate the expected amounts of hydrogen and helium and other elements in the universe, from the theory, and those do agree. I was talking to another physicist today who's looking at data from LIGO, and where we found that there are a lot of black holes out there, which is really surprising to me. And it turns out that from one of the phase transitions that you get from the Big Bang that you can, related to quantum chromodynamics, you can actually estimate the masses of these primordial black holes, and the estimates come out to be about 25 solar masses, which is what we're finding, in the data from the new gravitational wave detectors from LIGO. So,
wow.
So there's a lot of evidence that we've got a lot right about the Big Bang. Where it came from, what happens at that singularity is a big mystery. Is that a quantum fluctuation? Is it an act of creation? Is it, what? Nobody knows, and we probably will never know. But but you're right. It's a very interesting question.
And did time begin then? I mean, that's one of the things.
That's the idea. The idea is that time and space both began then. So asking what was before is kind of meaningless in some sense, and things get very, very complicated, from that perspective.
We're going into break in about 1 minute here, but since we're on this topic, just one of the things that you just mentioned, black holes, and I always like to talk to an astronomer about black holes because I think they're fascinating. And one of the things that I realized only like a year ago, or maybe even less, was that a black hole can't really have any more gravity than what was there initially. Like, for instance, a collapsed star can only have as amount of gravity as a collapsed star. Generally speaking, do these things move through space, or there are some that are moving through space?
Well, you can't really talk about anything being at rest in space. So everything's moving relative to something else.
Right.
So
Yeah.
things do move around. Yeah.
Okay. Well, let me.
The stars are moving. The stars are moving relative to one another, and so
Okay.
these black holes are probably as well.
Okay. So, all right. Let me just ask it this way then. Say that there was a black hole. That this collapse of a star became a black hole. Would that? There was no reason for that to move any more than it would have when it was the sun. Would there be any reason for it to move?
If you had a star that then went supernova and then collapsed into a black hole, it would continue to be moving relative to other things at that same velocity. So
Yeah.
that wouldn't change. Yeah.
It wouldn't change. Okay.
Yeah.
All right. Well, that's probably enough people want to hear about black holes and all that stuff anyway. So we're going to go into the break. So hang in, everyone. We'll be right back right after these messages. And welcome back. My guest tonight is Kevin Knuth, Ph.D., and we were talking about the dreaded black holes. Hope they don't find our solar system and wipe us out someday. Before we talk about other things, just one other thing when we were talking about the Big Bang, do you think it's a possibility that it could be a cycle that's happened before and can happen again, like expansion and then maybe contraction and, anything possible?
Yeah. I think, in that sense, I think everything's possible. Anything's possible. It's we just don't know. And that's been proposed. So it's an interesting question, and we probably won't ever really know.
Well, yeah. One of the things that's kind of depressing is to find out that everything might completely fall apart. All the molecules may just spread apart and everything.
Yeah, it's kind of sad. That's rather sad, right?
Yeah.
But
I don't care how many billion years it is from now. Right. It would just be hard to. It still could be depressing to think about.
Yeah.
Anyway, let's get into I want to get into a couple things in this part of the show before we take calls in a half hour, and that is the characteristics of these anomalous vehicles. Can you get into that kind of in a nutshell and what you came up with in that white paper?
Right. So in that paper, I looked at several cases. Two of the cases where there was, where there was radar data or the infrared images from the Nimitz encounters in 2004, and we also had a case from Graham Bethune in 1951 where he was able to. They were able to describe how fast the object came up at them from the sea surface, which was then corroborated later as it left by radar from Newfoundland. So I looked at these three cases to get some idea of how fast these objects are accelerating. So the most striking case was reported by Kevin Day, who was operating the radar on the USS Princeton in the Nimitz carrier group in 2004, and he was tracking these objects operating at about 20,000 feet, and they would periodically drop from around 20,000 feet or so down to sea level, and he was detecting them doing this in about 0.78 seconds, so about 3/4 of a second. So you basically have an object accelerating from vertical rest in the vertical direction to sea level in 3/4 of a second. So then it's basically some elementary kinematics or physics to figure out what the accelerations would have to be for that to happen. And so we basically did those calculations carefully by estimating uncertainties as well. And we found that in that situation, we had these objects had to, at minimum, they would have had to accelerate at about 5,300 Gs of acceleration to the halfway point, and then they'd have to decelerate 5,300 G to come to rest. Now, we don't know if that's the actual profile. We don't know if that's how they perform the maneuver because we don't have the detailed radar information on that. But that estimate gives you the minimum estimate for the acceleration. If they did something else, what that would imply is that at some point they would have had to accelerate greater than that. And so we do know that that's the situation. So 5,000 G, what is 5,000 G like? Well, what do I mean by that? What I mean is that acceleration is 5,000 times the acceleration of gravity. So, if you imagine a fighter pilot pulling 5 Gs, they're experiencing 5 times the acceleration of gravity. So if you weigh 100 pounds, you're going to feel like you weigh 500 pounds. And that's hard to handle physiologically. Now, what about 5,000 G? What would you look like? What would I look like standing up in one of these craft accelerating at 5,000 G? Well, all right, I'll be kind to myself. Let's say I weigh 200 pounds, all right? And so the upper half of my body would then weigh about 100 pounds. So if I was to accelerate at 5,000 G, 5,000 times the acceleration of gravity, then that means that my upper half of my body would feel like it weighed 5,000 times 100 pounds. So you're talking, that's a lot of weight. You're talking about 500,000 pounds. So it would be as if the upper half of my body weighed 500,000 pounds. But what happens to the lower half? Well, you can guess. You put 500,000 pounds on top of me, and I'm going to be squished into jelly. There's no way I'm going to survive that. And so that acceleration is more than shocking. Not only would you not expect an inhabitant, a biological inhabitant, to be able to survive that, you also wouldn't expect equipment to be able to handle that acceleration. Mm-hmm. So just to put that in perspective, our missiles can typically only handle at most 50 G of acceleration, and even in those situations, they can't maneuver at 50 Gs of acceleration. They can maintain their maneuverability up to about 35 Gs. So that's the best missiles we have, can really only withstand 35 Gs of acceleration and still operate properly. So 5,000 Gs is really shocking. How did some of the others compare? Well, we found the infrared video. So they released the Navy released 3 videos of these objects, and these are infrared videos. So they're infrared images. So they're blurry and fuzzy, which is in some sense unfortunate because a lot of people looked at them and said, well, I can't even tell what it is. It's some blurry, fuzzy object. It could be anything. In fact, I heard several of our prominent scientists say that publicly. It could be anything. Well, it can't be anything. You can rule things out. It's not a bird because the object is flying. The object at that point is flying in front of the airplane, in front of the F-18. The F-18's, going at something like 250 knots. So it's not a seagull. You know that. And it's not a normal drone if it's a drone because it's not some little propeller-driven drone with some guy with remote control, because you're not going to have that thing flying at 250 knots either. So in one particular video, the Nimitz video, there is it's unfortunately because we only got to see clips of these videos, and the videos that were the pilots, when they talked about these things moving, I think Commander Fravor described them as bouncing around as if it was a ping pong ball inside of a glass jar. So these things were really moving in very strange ways. We didn't get to see any videos like that. The Navy didn't release any videos like that if they have them, which is unfortunate because that would have been really interesting. What you do see is you see this in the Nimitz case, you see the object in front of the aircraft, and then eventually it moves off to the left on the videos. Mm-hmm. On the video screen, it is not that impressive of a maneuver, but of note, the missile, the targeting systems do lose lock when that happens, which is surprising because those targeting systems are designed to target missiles. So this thing clearly was an unusual acceleration. So we set about analyzing that acceleration, and we found that acceleration to be about 75 Gs.
Really?
So 75 times the acceleration of gravity, which was greater than the many of our missiles could withstand. Their airframes weren't capable of withstanding that kind of acceleration. So that object was clearly interesting. So it was exciting because they released what visually looked like a pretty tame video, and we were able to show that no, it's not tame at all. This is still an unusual craft.
Wow.
And that's really around the low end of the scale. We looked at the JAL 1628 encounter that happened in 1986. I actually remember that one being on the nightly news. I remember watching Tom Brokaw talk about it, and I was very excited. And basically, you had a pilot in this Japanese airliner. They were flying, and this is where the chuckle factor comes in. They were flying Beaujolais Nouveau from Paris to Tokyo. So yeah, no, the pilot isn't drunk. He doesn't drink the Beaujolais Nouveau. Let's be serious. It's in the cargo hold. So the pilot's flying, and they're flying across Alaska, and he basically encounters several strange craft in Alaska, and one of these objects flies up at the airplane, and according to the pilot, the object was so big he couldn't see out of the front windscreen without looking at the object. So when you have reports like that, very often, people will try to blow them off. Well, the pilot just didn't know what he was looking at. It was misidentification. He, blah blah blah. Well, it's not nothing if it fills your entire windscreen. Mm-hmm. You then have to take notice and pay some attention. And so he actually requested to make maneuvers to avoid this object, and this object stayed some distance away. I think it was something like, was it 7 kilometers away or something? It actually stayed some distance away from the aircraft.
Yeah, 7.5 miles away, actually.
Yeah, 7.5 miles, that's what it was. And but basically it would go from, on the radar reports, the radar shows it going from something like 1 o'clock to 6 o'clock in 12 seconds. With every radar, the radar sweep was about 12 seconds. And so this object is basically, according to the radar, is bouncing around the aircraft, the jet airplane, the 747. So then the question is, how do you get from 1 o'clock to 6 o'clock in 12 seconds? When the radius of this circle is 7.5 miles, well, you can estimate the accelerations there. So if you estimate it going straight across either over the airplane or under the airplane, then you get an acceleration something like 68 Gs of acceleration. So the thing would have to accelerate halfway and then decelerate the other half. If it goes around on the circle, basically goes around the airplane, you have to have a tangential acceleration of about 84 Gs. So again, this thing is moving dramatically. The pilot described it as being about the size of several 747s.
Right.
I think it was
like
3
a giant walnut.
747s.
Yeah.
Like a giant walnut. So basically the size of 3 747s, you're talking about something the size of an aircraft carrier just flying around a 747, and this went on for almost an hour. It wasn't
300 miles or something.
Like 300 miles. It wasn't a quick sighting. It was, this went on for a long period of time, and and the pilot, and so the other issue that then comes up is the question of air safety. Some of these encounters are not safe, and the pilots don't feel safe, and that's a problem if your pilot is not feeling safe. And so there's another reason to study these as well. Mm-hmm. So that acceleration, one of those accelerations, the 68G, is actually at the low scale. So we've got these craft accelerating anywhere between 68 Gs up to 5,000 Gs of acceleration. And the problem is we really don't know how these things are flying in the first place, because they don't have flight surfaces, they don't have obvious control surfaces, they don't have an obvious power plant, so it's not clear, where the thrust is coming from to keep these things moving. And that's especially evident in the infrared video when you see that the Tic Tac object that they described as accelerating off to the left. If it's accelerating at 75 G, And you don't see flames coming out of the thing. This is an infrared video. There's no extra heat being dumped into the environment. So how does this thing work? It's not clear at all. And I've heard criticisms, people have criticized the analysis saying, oh, well, you don't really know that it was 50 feet across. That's what the pilots described, but the pilots could have been wrong. Maybe it was only 5 feet across. And my answer to that is like, well, all right, do the math. Don't just make the argument, the verbal argument. Let's test this, do the math. So let's assume that it's only 5 feet across. That would have put the object much closer. And you basically get a factor of 10 less acceleration. So, okay, so the thing accelerated at 7g instead of 75g. I'd still like to know how you take a 5-foot-long object and accelerate it at 7g of acceleration without any heat signature. You still have this question is still there. It doesn't go away, even if they were off on its size, if they were mistaken about its size by a factor of 10, the problem still exists. So
wow.
This is serious. It's not a joke, and it can't be anything. And you can determine that by doing the math. And I find that disappointing when I hear some of our prominent scientists, coming out and saying it could be anything. Well, none of them sat down and did the math. The math isn't especially hard to do. It's, a first-year physics student could do the math in some of these cases, but we see these prominent scientists making these blanket statements without having done the math, and that's problematic. And
I'm glad you say that, and I hope if you get a chance to call them out and feel comfortable to call them out that you do. And I don't know what type of situation that would be, but I'm glad at least you are looking into this and put the effort into it. A few times you said the word we. So what do you mean by we? Were there a lot of people helping you with this situation?
Oh, I did some of this work with Robert Powell and Peter Reale, who are with the Scientific Coalition for UAP Studies. So.
Yeah. Well, that's great. I had an email exchange a couple of days ago with P.J. Hughes, who was involved in the Nimitz case. And he basically said before that, back when he was on the show, he was 50-50 on whether it was, special tech instead of, he's talking about the Tic Tacs. And now he says he's 60-40 that he thinks it's tech. And so I contacted him, and, he told me a couple of things to keep under my hat, but he said basically, his thoughts have changed, that it's more likely that it was tech. But I want to argue this. Or many things, actually. I don't understand what tech we could possibly have today that could absorb the type of G's you're talking about. I mean, even a rock would have a problem. Then also, you talk about the JAL 1628, is it?
Yeah. Yep.
When that happened, there was also G forces beyond what we could handle today. So. And that was back in 1996, I believe it was.
1986.
1986.
Yeah. Well, the Bethune case is from 1951, and those estimates come out to about 1700 G. Wow. That's 1951. I think, yeah.
So if we had any tech like that back then, there's no way we wouldn't be using it before now.
Yeah, that's my argument. You're not gonna sit on technology like this for 50 years. That's a lot. That's a person's career. Nobody's gonna sit on that for 50 years. I find that really that's a difficult argument to swallow.
Yeah.
And these things have been seen since before we could fly in airplanes. So you've got that problem as well. You can argue about the validity of a lot of those observations, but I would argue that they're not all ridiculous. So those many of those observations sound a lot like the ones that we have, that we've analyzed here. So this is a really difficult situation.
Well, thank you for doing that work. That paper is pretty intense, 19 pages long. I'm going to try, for the listener out there, I'm going to try to put that up in the show notes on this show, which will be up for a week on podcastufo.com. So wander over there I'll try to do that this evening. It's a PDF, and sometimes those are really hard to embed. I'm going to see if I can do that on my website, so check it out. Probably starting on Wednesday, the 11th of this month. That's tomorrow. I might have that up and running. So,
Right.
so that will be available. Now let's
So
talk. Go ahead.
can I
Yeah.
interject another point, especially in the Bethune case? So that was the 1951 case. The pilots and passengers estimated the thing left at a speed of about 1,500 miles an hour. That was later confirmed by the Gander Center radar in Newfoundland to be 1,800 miles an hour. And that's
Amazing.
1951. So I did some research on this and found that in 1952, 2 years later, almost 2 years later, you had the airspeed record from General J. Slade Nash flying a F-86D Sabre was made at 698 miles an hour. That was the airspeed record in 1952. And radar and the pilot and passengers estimated this thing to be going about 15 to 1,800 miles an hour. So these things are really anomalous. And they're anomalous to the point where it as a physicist, I feel a lot of skepticism. You have, for the one that Kevin Day tracked and saw descend 20,000 feet in 0.78 seconds, you're talking accelerations of about 5,000 G. What that means is that at the midpoint, the object had to have been going about Mach 60. And so Mach 60 is something like 45,000 miles an hour, which is faster than some of our fastest spacecraft. New Horizons that went to Pluto is only going 35,000 miles an hour. So this Tic Tac, in less than a third of a second, accelerated to a speed greater than the probe that we sent to Pluto.
And we got to also keep in mind the friction of the atmosphere.
Oh, well, that as a physicist, that's the big worry. You expect there to be a huge, your first thought is sonic boom, but it's going to be much more than a sonic boom. We estimated the amount of energy release would have had to have been equivalent to about 200 Tomahawk cruise missiles going off at the same time.
Wow.
That's what you should have seen when that happened, but it didn't happen. That's not what we saw. The thing moved through the air like the air wasn't there, which is really, from a physics and engineering perspective, really problematic. And it leads you to question the data. It leads you to question these results. You think, how is this even possible? But I'm going to contend, as I always have, but this is the data we have, and this is what people have been reporting for years, and I think it's time for us to pay some attention.
Yeah. And for, someone out there pondering all this, think of the Chelyabinsk meteor, what that caused, blowing out windows everywhere and in Russia when that came through the atmosphere. And that was about that same speed, 40,000 or so.
That's probably, yeah, it couldn't have been much, it couldn't be much more than 60,000 miles an hour. So you can't be much more than that. Once you get into the 90,000 mile an hour range, it's going to be interstellar. So it would have to be less than that, certainly.
Right.
Yeah. So it's probably on that order of speed, and that's what you had happening, and that's that meteorite was blowing out windows and injuring people. And that's really what should have happened in this case, but that's not what's observed. And so I like how the British, I'm told, calls them those people, because of course we don't know who've created these craft and who they are. And so
wow.
assuming these are structured craft, we'll call them those people. I like that phrase. So whoever those people are really good engineers. They really know what they're doing, and I'd like to learn. I'd like to know how to do this, and because it's quite exciting.
Yeah, there's the beam ahead. Have you ever heard of that? I don't know if it's a theory of technology that's supposed to do something. I think Ray Stanford knows something about that. Maybe when he calls in, we can ask him. But we only have a few minutes before we're going to be turning on the phone line. So let's talk about your other work, Constraints on Breakaway Societies Engage in Relativistic Interstellar Travel. We're going to have to
Right.
kind of do that in a nutshell if we possibly can.
Yeah,
We can talk through
I can
the
try to sum that up. Yeah.
we can talk through the phone calls on that. Go back to it. You never know how many we may get. One or two phone calls. We may get more. We never know. So
Okay.
why don't we get into that topic?
Yeah. So one thing that had struck me is that physicists have known for a long time that if you could get a spacecraft up to relativistic speeds, and by that I mean some reasonable percentage of the speed of light, something like, above 30% the speed of light, then you can take advantage of the time dilation that you get from special relativity, where your clocks slow down, right? So this is all related to the twin paradox. So the traveler doesn't age when he comes back to Earth, and in that problem. So the idea is that once a spacecraft is going fast enough, their time slows down, and so you can travel greater distances, and for the traveler it will be a shorter period of time. The problem is that when you turn around and you come back to Earth, it will have been a long period of time for those people back on Earth. And so, for example, if I could travel very close to the speed of light, I could travel to Alpha Centauri in a very short period of time, maybe a few hours, if I was going 99.999 some percent of the speed of light. So I could maybe do this in a few hours and then turn around, explore Alpha Centauri a little bit, and come right back. And for me, the total travel time would be a couple of hours, maybe a day or so, depending on the numbers we chose. But because Alpha Centauri is about 4 light years away, for people on Earth, they'll have seen my trip took me 4 years to get there and then 4 years back. So 8 years will have passed on Earth. And so while relativity works for you as the traveler, it doesn't help everybody who has to stay at home. So the argument has always been, well, yeah, you could do interstellar travel if you went fast enough, but what's the point? Because when you come back home, many years will have passed, and that's just not, you can't come home in time for dinner. So it doesn't work in science fiction stories, because you want your heroes to go blow up the Death Star and then come back and be home in time for dinner. But so that wouldn't really work. So the question has always been, so let's say you have somebody who travels from here to the other side of the galaxy and then comes back again. And if you go very fast, close to the speed of light, the traveler can actually do it within, a reasonably short period of time. But for those left here back on Earth, the trip was going to take, 150,000 years, and so the question then becomes, well, what society would do that? Why would you bother? So it's physically possible to perform interstellar travel this way, but what's the point? And that I was thinking about that argument one day, and it occurred to me, I thought, well, the point's really simple, because the traveler gets to take the trip. If the traveler doesn't care about anybody back home, he still gets to go on an adventure. He or she gets to still see the other side of the galaxy, and yeah, they don't get to share it with anyone, but they got to do it. And so is it really true that nobody would ever do that? And I thought, well, no, of course that's not true. Humans are crazy. Humans would do it.
Yeah, we sign up to go to Mars. Yeah.
I'm sure I could find somebody to take that trip, and I'm sure I could. And then it occurred to me, I thought, but then wait a minute, but if you had many people who are willing to do that, then you could actually pull it off, because they could meet up and talk about their adventures. So they could form what I would call a breakaway society, which is, by that term, I don't mean it the same way that Richard Dolan means it when he uses that. So here it would be a society that is segregated from our society, basically a society of travelers. And you could live that way. You would just have to live on your spacecraft and be nomadic. So you basically give up the idea of having a home world or a home planet. But you could have meetup points where you either pre-arrange or you design your trips so that it just happens to work, that you will periodically meet up with fellow travelers. And then you could easily have, a civilization that travels across the universe regularly and goes great distances, and still still persists. So I think that it's a little, if you think out of the box a bit, you can come up with a solution where somebody would do that, and you could have a society that behaved that way. And that doesn't mean that all interstellar societies would behave that way. You could still have societies that basically colonize other worlds and just slowly expand. Um, those people might not be traveling back and forth between star systems regularly, but so that would be a different situation. But you could have a society where people were traveling back and forth regularly at very close to the speed of light. If you could pull that off. Now, of course, there's all sorts of engineering challenges in addition to the ones we've already discussed that would be problematic.
Now, does physics allow for you to go back in time?
That's messy. It looks like according with general relativity, it looks like you could do that. However, if you, let's say you made a time machine where you went back in time, you can show that would only work. You could only go back in time as far up until the point where you had made the time machine. So you can't go back in time before there were time machines that were traveling in time. So it's a kind of a messy situation. So the answer is potentially yes, but with a few caveats.
So in other words, if someone did do space travel and they were so out of whack with Earth, yet they had invented a time machine, then they could actually go back to their time. I mean, this is all.
Yeah, the time machine would have had to exist at the time that they go back to. So
yeah.
So there's been the proposal that some of these UFOs or UAPs may be the result of craft traveling back into time. As far as we understand it, and as far as I understand it at this point, that would be possible, but it would also imply that we would have, if we were seeing that, then it would imply that we have time machines right now. And so
I see.
So
wow.
So there would be some big implications here.
Does your brain ever hurt?
All the time.
Mine's
it's always exploding. It's just exploding inside its skull all the time. Yeah.
Oh, pretty funny. Wow. Yeah, I mean, you can get, as they say, down the rabbit hole with a lot of this stuff, and the paradoxes and all that. It's really fascinating. I'm really enjoying myself tonight. Just to let you know that.
And what I think is really exciting is even if none of these are extraterrestrial, and even if they're just high tech that we don't know about yet, then we basically right now live in a Star Trek universe. We have the possibility of having space travel like they have in TV shows like Star Trek or Star Wars, and I think that also is exciting. So even if these turn out to be American special projects, that implies that these things are capable of interstellar travel, and that's interesting. But I then would expect that there's going to be a lot of really pissed off aeronautical engineers, thousands of them, who have worked their whole lives to develop the next generation aircraft or spacecraft, and are going to be really mad that this technology was kept from them, right? And that's gonna be a problem, and it's a huge. You can also think of it. Our government has this. Well, great, but it's a huge waste of money. It's a huge waste of money to be throwing, $19 billion a year at NASA so we can putz around, 125 miles above the Earth's surface. That's kind of silly. So it's really hard for me to believe that these are tech that we possess. I really find that difficult.
Do you think the government is just as puzzled with UFOs as we are?
That's my take on it. My take is they've collected, there are some programs in the government that's collected a good bit more information than any of us have seen, but my impression is they don't know much more about these things than any of the rest of us. Yeah,
that's kind of been my take all along. I think I used to say that I believe that some part of the government possibly has more of an idea about what's going on than we do, but I really don't know. Like I said earlier, it seems like the more I get into this, the less that I know about it. So, I go ahead.
I would
Yeah.
suspect if there was, you know, a program or a couple of programs even that had significant information, that we would be far more worried about it. That would be my expectation. Now I could be mistaken, and that may be, and the evidence of being mistaken about that, may be that we've got a lot of people from the Navy who are just flummoxed that nobody cares about this. So maybe it's the incredulity of the whole topic is still problematic. I don't know what the situation is.
Yeah, I'm a fine arts appraiser. I was at a home down in Massachusetts, and I saw Navy bumper stickers on the back of a car in the driveway. And I said to them, "Oh, so you have someone in the Navy?" And they said, "Retired Navy." And I said, "Oh, by the way, what do you think of?" I had the courage, because it's tricky to talk about, but I had the courage
It really is.
to ask. And she said, "I know my husband's been following that. He can't believe it. And how interesting is that?" And it's both baffling at the same time. It's great that they're actually looking into this, and I believe it opens the door for people like you a little wider, doesn't it?
It really has. It's made it easier as a scientist to look at this, because I really, if I mention this to another scientist and they, cock their head and furrow their brow a little bit and say, "What?" and I just have to point and say, "Navy, U.S. Navy." The U.S. Navy says, and that, while they're not an authority on the topic, they do carry some credibility, which is, very different than Joe Schmo who came out of the bar at 2 a.m. and saw some lights in the sky. It's a very different situation.
That's right.
And I think, that's really helped. That's helped a lot in, people then give you, I found other scientists then give you the benefit of the doubt. All right, you got a few minutes to convince me, and that allows you to present some of the evidence that they've not seen because they haven't looked into it. And the typical response is that, "Wow, I didn't know all of that. That's amazing." And then it's usually followed by, "But I'm still skeptical because of the way that these things fly. That's not physically possible. So how does this work? Are you sure this isn't wrong?" And that leads to a whole other, but a more detailed discussion. And that's a discussion we should be having, because that's how we're going to figure out what's going on.
As someone like yourself, a scientist, you have much more of a foot in the door to actually talk to someone about this the way you are. It just works. For someone like me or anyone else out there, us Joe Schmo, so to speak, it's hard. We bring it up in a conversation, and most people, not all people these days, I feel more and more comfortable with it all the time. But most people, a scientist isn't going to listen to, but a scientist to a scientist, they pay more attention for sure, I think.
Right, and I think that, yeah, there's a bit of a difference. We speak the same language. We know, we have a better sense of what information is relevant and what's not relevant. We have a better sense of what's believable and what's not believable. We're trained not to jump to conclusions, and which I think a lot of people are prone to do.
Right.
And you get talking to people just casually, before you know it, there's all sorts of theories popping up that, whoa, I think it's this and this and this, and I think it's dogmen and Bigfoot and coming out of spacecraft and blah blah blah, and you think, well, wait a minute, let's back up here. Let's back up. Do we have actual data about? Do we have actual information? And so as a scientist, it's easier to do that and to keep in mind, what do I actually have? Um, what can I prove, based on the data that I have? And that's basically why I wrote this paper. I realized that, well, we have enough information here. We can actually estimate some of these accelerations and speeds, and that would be an important first step in understanding what these things are and how they're moving, and allow us to rule out some hypotheses.
Exactly.
It's not a seagull accelerating at 5,000 G. And I had somebody actually ask me once, do you think it could be a highly reflective seagull? And as a bird watcher myself, I had almost exploded. I was like, there is no such thing. You think that's more probable than aliens or anything else? That's crazy. But yeah, no, it's not a highly reflective seagull. We know that.
Yeah.
They can't be anything. We can rule out some of these things at this point.
Right. That's a riot. So the lines are open now for anyone out there that would like to call in. That's 85 KGR8 live, or 855-472-5483. We have Steve from Las Vegas. Steve, welcome to the show.
Thank you, Martin. Hi, Kevin.
Hello, Steve.
Just two quick questions, maybe. I'm so intrigued and interested in what you're talking about here, and I'm thinking to myself, well, you're talking physics, and is this science that you're bringing into you about? Because we need more scientists to look into it, like Stanton Friedman said, and some of your friends, other physics, looking into it and agreeing with your philosophy.
Yeah, so this is basically what I'm trying to study these things scientifically. I want to know what they are, I want to know how they work, and I want to know the details. And so that's what I'm trying to do. I have a number of colleagues who are also interested in studying things, and we're trying to do our best to. We're trying to figure out how to collect data. That's the important job right now, is to collect our own data, to use better instrumentation, and see what we can actually learn about these things.
Okay, and my second question is, I collect footage of UFOs. I use the term UFOs instead of UAP.
That's fine. That's fine. I think of them as the same thing anyway as well.
And most of the footage that I've been collecting, even up to now, I would say about 60% are orbs that seem to appear, disappear, and move around in patterns that is unbelievable. My question is, to me, I've tried to figure it out. Well, it seems like they're intelligent, these orbs, and light is energy. What could be behind? Can it be some kind of intelligence, light, that could be these orbs?
That's hard. That's hard for me to imagine. That you could have light be intelligent. And as to the nature of these orbs, I can't really speak to that, having not seen them myself or had footage that I could really do anything, with in terms of image analysis. So that's a difficult question. Intelligence, the way I think about it, when intelligent things basically create models of the world around them so that they can interact with the world around them. And so if you're an intelligent being or object, then you have to be able to create such models. And I don't see how light could just do that. Light, basically, you've got photons, they travel from point A to point B and get absorbed somewhere. So it's hard to imagine how to have an intelligence that's just basically made of light. So that's hard for me to imagine, but that doesn't, it sounds like these, a lot of these things would need to be studied more carefully to be able to identify what they are.
We have calls backing up here. So, Steve, yeah,
thank you.
Thanks for the call.
You're welcome. Bye-bye.
Bye. All right. Look who we have here. We have Dave Altman calling, probably from Florida. You there these days, Dave?
Yes, I'm here in the sunny, actually rainy, miserable Florida.
Hello, Dave.
You know the guest.
Yes, I do. We are both members of the UAP expedition group.
Oh, you're involved in that too, Kevin.
Yes, I am, and I'm at this moment very, very sorry that I hadn't mentioned that yet. So thank you for calling, Dave.
That's exactly why I called. And I also just wanted to let everybody know that the website has gone live. It's not done, but it is live, and it is uapexpedition.org. That is the website.
Brilliant. Thank you.
Dave, when you get off the phone, why don't you go ahead and send me that link, and I'll put that in the show notes for everyone. I did post it in the chat room, but I'll send it to you as well. This way you have it for your show notes. And also just wanted to remind Kevin that we're all going to be at Contact in the Deserts at the end of May, beginning of June.
Yep, that's right.
That's right. And I'm slated to go there too. So,
brilliant.
So that will be great to meet everyone there.
So we'll all be able to have a little powwow and get to know each other in person.
Excellent. That'd be great. Well, hey, Dave, thanks so much. We got a bunch of calls backed up here. So
yeah, thank you very much, Dave.
All right, and so everyone, look for that link in the show notes, and I'll have that open. Next, we have, and I see Ray is on the line here too, but we have Andy calling from Connecticut. He's the one who saved the show a while ago when I had to have a listener show. And Andy, don't forget to call next week.
Absolutely, I will.
Welcome to the show. You have a question for our guest, Kevin?
Yeah, I have one quick question that I'll ask, and then I'll get off the phone. And I apologize if you might have touched on this earlier. I didn't hear the whole show. But my question is, what are Kevin's thoughts on the concept or theory that's gaining popularity with some physicists that gravity is actually what we experience is a distortion in the fabric of space-time created by the Earth's own mass. And there are some analogies out there like bowling balls on trampolines with marbles trying to go by and they can't go by, and they get sucked into that distortion that depression created. Does he think that that's probably valid? That's what gravity is. And I'll take your question off the air. Good show, guys. Thank you.
Thank you, Andy. Talk to you next week.
Thank you, Andy, and hello. That's a good question. That's basically the picture that one gets from Albert Einstein's general relativity, which is a very successful theory. So I think it's a very good description of and a good picture of what is going on with gravity. Is there something more fundamental? Might be the question you could ask, and I think that's probably the case, and I think that's what many theoretical physicists are trying to understand by studying quantum gravity. We're trying to understand the relationship between quantum mechanics and gravity, and at present Einstein's general theory of relativity doesn't get along well with quantum mechanics, and so the thinking is that there's probably a more fundamental picture that will allow us to understand gravity better. And I think it's an exciting area of research, yeah.
Speaking of exciting, I was just thinking of that word where it must be exciting to you as a physicist to know that you haven't discovered everything.
That is exciting. That is really exciting. I had, I remember when I was about to go into graduate school, I kind of lamented to my parents. I thought, oh my God, I really am excited to study physics, but it's horrible. All the cool things have been discovered already, and I'm not going to be able to do anything as fundamental as what Einstein did, and I kind of lamented that, and it's turned out not to be true, which is great. I've done some theoretical work. We've got, I've been able to derive some of the laws of quantum mechanics from simple symmetries and things like this. So I've gotten to be able to do some real foundational physics work that that is new and interesting. So I think it's very exciting. I couldn't imagine doing anything else for a career. How boring, in my mind.
Wow.
It would
Yeah.
be.
I'm lucky enough to say, believe it or not, that's how I feel about the antiques and fine art, and because there's so much history and research in it, I love it. By the way, for the listener out there, I also do a podcast on antiques and fine art called the Antique Auction Forum. If anyone wants to go check that out.
Wow.
But anyway,
I think it's fun that whenever I've found that whenever you study anything, you can find something interesting in it, and I found that to be the case, and that's always great.
Yeah, that's right. Well, we have about 5 minutes left. Someone's trying to call in, but we also have Ray Stanford on the line from Baltimore. Ray, welcome to the show.
Hello. Hey, I am thrilled to hear Kevin say that he would like to meet me, and I hope he would like to visit down here in the NASA Goddard territory.
I would love to. It's such a pleasure to meet you.
There's a tremendous amount that I want to share with you, and I'm delighted to hear you say that, look, it's not more pawing over old reports that we need. We need hard data. We need instruments out there. And what I want to share with you is that class of data in a way that I think you will be delighted. And I wouldn't invite anybody to fly in here in planes these days with the virus going around, but if you're in New York, heck, you could drive down.
Oh, that's true. Yes, certainly. Yeah, I would very much love to. I'd be very interested in hearing about. I know that you have an interesting collection of UAPs or UFOs and photographs, and I also would be very interested in the paleontology too. So it's very exciting.
I visited Ray. I don't know, what was that, 3 or 4 years ago, Ray? When I was down there.
3.5 years ago, yeah.
Yeah, when I was down there, and I got to tell you, now I go into a lot of houses with amazing collections of all kinds, mostly art, stuff like that. I've never seen a collection like Ray has.
That would be great.
Meteorites, Ray, I hope you don't mind me saying that, but you just have some fascinating things.
Yes, and we'd love to show these to Kevin. And Kevin, also, I want to say that if you can give yourself enough time down here, I would also be happy to take you on a dinosaur tracking trip.
Oh, that would be so great. That would be fun. Yeah, my father and I had gone to the Badlands in South Dakota several times when I was young, and of course not in the park itself, but we had collected some fossils. So I have an Oreodont skull that I had found and restored, as well as a tortoise, and so I have my own little collection. But that's very exciting.
Well, I would just like to ask Martin to pass on to me the best email address to send you. I'll send you some material and links that you'll find them really exciting about both sides of this. The objects, yes, I prefer objects too instead of phenomena, and
right.
And the paleontological side. I don't want to hold anybody else up from calling in, but thank you for your interest, and do please plan on coming and see me, and I'll give you the contact information, and we would welcome you here any amount of time you want to stay. Okay.
Oh, well, thank you so much. That's very kind of you.
Hey, Ray, just for we have 2 minutes left, basically. But, Ray, weren't you involved in, at least thinking about some type of craft propulsion that had a beam ahead? Or am I getting that wrong, Ray?
That is correct. Yes, October 5, 1985, a lot of us witnessed, and I filmed in Corpus Christi on the bayfront in broad daylight. Beautiful film of 4 different objects that were dish-shaped with a dome, but they had a structure on the other side that projected a very narrow collimated beam out about 30 diameters ahead of it. And I will show you from this movie, I'll show you the frames, and then I'll show you the image process with false color contouring, and you will see, like in a Schlieren view, you will see the actual patterns of the plasma being generated in front and pulled around the object and squeezed in and back as if it were a spoiler. And you will be, as a scientist, I think you'll be delighted at what you see.
Wow, that sounds interesting.
Yeah, and so much more. I mean, people from Goddard have actually gone over to Ray's house and looked at some things, which I think is great. Ray,
Wow.
I really am so glad you called in, and I will make the connection of you two.
Thanks. I appreciate it. I'll go
Yeah.
now.
No, thank you so much.
Looking forward to seeing you, Kevin. Okay. Thank
Great.
you.
Thank you.
Bye-bye.
Have a good night, Ray. So we just have 1 minute left. If someone wanted to reach out with you, I saw that you have a link we have in the show notes to. It's actually to the university. Do you have any problem with people getting in touch with you?
No, that's fine. I'm a professor, and people can email me questions anytime they want. That's fine. Yep.
Okay, excellent. Well, and you don't have a website though, right?
I do have a website.
Oh, okay. I'm sorry I didn't link that. Go ahead. What is that?
Yeah. Let's see. Well, I'm actually our websites are transitioning right now, so I've got a new website that I put up, and I have to fix it a bit, but it's knuthlab.org.
Okay.
And I've got to do a little bit of work on it to get it. Right now it just says got new host, so that's not the whole thing. So I've got to put a little file in, and I'll have that fixed by tonight.
All right. Kevin, thanks so much. We're totally out of time. I really appreciate it. It's been a real pleasure tonight.
Oh, thank you so much for having me.
All right. Okay, everyone, that's it for the show. And I want to thank you all for listening. And we'll be back next week with a listener show. I hope all listeners will make an attempt to call in. I'd love to talk to you. And remember, everyone, to keep your eyes to the sky.